Okay, last video for hereditary information. We're going to talk about some of the problems, some of the questions that maybe you guys would have to go through and answer. Again, if I were you, I would probably go back or at least go online and find some of those packets that we worked on, primarily the trihybrid crosses, dihybrid crosses, just any of those situations that could possibly come up. So I think what we're going to do is we're going to start. Um, I'll kind of go through. Just remember pedigrees. Being able to go through and read a pedigree. I can't say that anything's going to be on there dealing with it, but again, you just never know. Punnett squares, obviously, the monohybrid crosses, dihybrid crosses could be pretty easy as we go through. But I think, kind of as we talk, we want to make sure that we are having a good understanding of, again, the laws of probabilities and when we can use versus one versus the other. Excuse me. And again, I think kind of the keywords that we start looking here is that when we start looking at the word and versus or. And so in the rules of multiplication, we're looking at basically a problem to where, let's say that, again, you have two heterozygous individuals, and what is the chance of actually ending up with a homozygous recessive? And again, when you go through and take a look, well, there's half of a probability of getting a little p, half a little p, because this is an and. There's a little p and a little p. You're going to multiply those two together, and you're going to get to 1/4. So a lot of our trihybrid crosses that you guys worked on, you're dealing with the rules of multiplication, because you're looking at specific genetic specific genetic combination that you wanted to get. And so we'd be using the rules of multiplication. So make sure you guys go through and, again, just kind of have an understanding of when to use the rules of multiplication. Again, with the rules of addition, we're looking at an or kind of a situation. So and this one's a little bit more tricky because, again, you've got to understand the situation of, if I've got, again, those two heterozygous parents, and now I want to end up with a heterozygous individual at the end. Well, this comes back to being an or, because I could get the big P little p from these parents, and that could get the little p and big P from these parents. So this actually ends up with this combination or that combination. So when I go through and figure this out, I'm using the rules of multiplication, because there's a chance of getting the big P and the little p. So I'm going to multiply the halves together to get 1/4. Again, halves together to get to 1/4. But the real question that I'm trying to answer is the probability of getting the big P little p. So there's a 1/4 probability from here, 1/4 probability from there. Add those two together, and you've got a 1/4 chance in order to get that. So again, when to use those, and I think it's going to help out your guys' Punnett squares considerably as you guys go through and work on those. But just making sure that you guys have a good understanding for when to use them and what is being asked of you. Again, with the pedigrees, pretty simple in that you've got the males versus females. You've got, in this case, two are married. Here are the offspring. Offspring have gone out and gotten married here, again, married here. They've had their own children. Their children have gotten married and had children, and so on down the line. And I think as we look at these pedigrees, I'll go to one that's maybe a little bit more extensive. We start kind of throwing in a couple of the rules. One, if you're seeing it in every generation, such as 1 to 4 to 7, 1 to 5 to 8, I think we could probably all agree that this is a dominant condition. When you start looking at situations to where it is skipping generations, right? In this case, we're probably looking at a recessive condition. Let's just say, for example, if we're looking at recessive, be a little a. Parents would be big A, little a, big A, little a. Again, they're not going to have that condition, but they can definitely pass on the little a's to this individual right here. So I think that's kind of the biggest part that we just need to understand, again, is those dominant versus recessive conditions. Now, we also talked a little bit about chi-square analysis during this time, and kind of we were going to go through and work on the corn labs, which we didn't. I think we went through and kind of discussed the skittles and the randomness or the chances that you actually end up with all 5 color combinations. Say hi, Creighton. Okay, so chi-square analysis, again, that will be given to you, the actual the formula itself, but you guys also have the ability to do these on your calculators, and I would make sure you guys have that built in, or at least an understanding of how to do that on your calculators and make life easy for you guys as we go through. So chi-square analysis was another one of those tests, and again, we're just kind of looking at the statistical significance of data. And so when I start looking at again, we generally used the 0.05, the one with the 3.841. Please don't right now. Okay, 3.841. When you go through, you're going to calculate, the obviously chi-square value. And then in order to figure out your degrees of freedom, you have your total number of data points or sample points, subtract that by 1, and that's going to give you your degrees of freedom. So when we had the 5 colors of the Skittles, our degrees of freedom would actually be 4 because there's 5 possible combinations minus the 1 gives us 4 for degrees of freedom. We take a look at this guy right here. Our chi-square value would be 9.408, I believe is what that number is. And so when you guys went through and figured out your numbers, if your number was above 9.408, speaking respectively to the Skittles, it generally mean that there is something that is altering that combination and making it completely different than what it possibly should be, because we're going to expect a little bit of differences. We're going to expect random differences as these experiments or this research goes on. Now, if those numbers are found underneath the 9.4 as far as the Skittles bag go, then that's telling us that, yeah, there's difference, but there's not enough statistical difference to really go through and be alarmed by that whatsoever. So again, have that understanding of the chi-square analysis. But for the problems, again, the pedigrees, the Punnett squares, chi-square analysis, the law of independent, the law of multiplication, law of addition, and when to use those. Just a really good understanding of being able to answer any of the questions that they may be throwing at you with the genetic problems.